Okay, this is a doozy of a problem. We're going to be solving down an exponential equation, and it's exponential because our variables are up in the exponent. Now, we have to take a little bit different direction on this than we may in other situations. We can't use the one-to-one property of exponential functions because we're not going to be able to rewrite our bases so they're the exact same. All right, 9 is just 3 times 3, and 4 is 2 times 2. We can't rewrite them so they have the exact same base on both sides. So with that, we're a little bit limited. Instead, we're going to have to get a logarithm involved. So we get the rules that go along with logarithms. The first rule that we want to be able to utilize is this power rule, written off to the right-hand side, which basically says if you have an exponent attached to everything on the inside of your log, what you can do is you can move that exponent down in front and make it a multiple multiplied by the log. All right, so we have to get a logarithm involved. I'm going to choose a common logarithm in this case. We typically choose either the common logarithm or the natural logarithm because we're allowed to use our calculators with those two. All right, so this puts us at 9 log of 9 raised to the 10x minus 5 equals, we also have to apply that to the right-hand side, log of 4 raised to the 10x minus 9 power. So each side actually got plugged into the common log. But now using this property or this rule, these exponents, since they're attached to everything on the inside of the log, can move down in front. When we write them down here, though, we have to be a little bit careful that it's going to be 10x minus 5 multiplied by the log of 9 equals that entire exponent. That's why I'm using parentheses, 10x minus 9 multiplied by the log of 4. And I know this looks to many students as though it's a very difficult problem to solve down, but notice that all of our x's, the variable in this case, is only raised to the first power. So we're just going to have to use our algebra to do some rearranging and solving down. All right, so the rearranging that I'm going to do is I'm going to go ahead and distribute that log of 9 to both these terms on the left-hand side. So that's going to give us 10 times x times log of 9 minus 5 times log of 9 equals, and on the right-hand side, very similarly, we're going to distribute that log of 4 to each one of these terms on the inside of the parentheses to get rid of our parentheses. So we have 10 times x times log of 4 minus 9 times log of 4. All right, so we have two terms that have x's, and we have the other two terms that don't have x's. They're all constants with that log of 9 and log of 4 respectively. So our next goal is get all the terms that have x's on one side and all the terms that don't have x's to the other side. So first, let's move all the terms with x's to the same side. So I'm going to subtract 10x times log of 4 to move that over to the left-hand side. All right, so we have 10x times log of 9, bringing that down, minus 10x times log of 4, minus 5 times log of 9, equals, now these got canceled, right? One was positive and we subtracted another one away. That's the red does not indicate division by any means. And then we'll bring down the minus 9 times log of 4. All right, so the terms that have x's are both on the left-hand side. This term with the minus 5 log of 9, we want to move it to the right-hand side. So we're going to add that to both sides. 5 log of 9. Subtracting and adding, the same thing makes 0. So at this point, we're left with those two terms that have x's on the left side. What I'm going to do next is these both have an x as a common term. So what we're going to do is we're going to factor out a common factor of x. So if we pull that out, we have x multiplied by 10 times log of 9 minus 10 times log of 4 on the left-hand side. And we're going to have positive 5 times log of 9 minus 9 times log of 4 on the right-hand side. Now, why we wanted to factor out the x and maybe not a 10x, even though that was a greater common factor, is our goal is to get x on one side by itself. And we've created a situation where we have x multiplied by the entire rest of the left-hand side. So to get x all by itself, what we need to do is we need to get rid of that entire big set of parentheses. Because they're connected with multiplication, we're going to use division to accomplish our goal. So divide both sides by 10 times log of 9 minus 10 times log of 4. Multiplying and dividing by the same thing will create a 1. That'll get x on one side all by itself. And that's a correct solution, an exact solution. We may choose, however, to rewrite this, and we can make it look a little bit nicer. What we can do is, remember back to our power rule for logarithms, if you have a number multiplied out in front of a logarithm, you're allowed to move that up to the exponent and attach it to everything on the inside. So we're going to be doing that with this 5, this 9, the 10, and this other 10 can all move up into the exponent. So that's going to give us a log of 9 to the 5th power minus log of 4 to the 9th power over log of 9 to the 10th power minus log of 4 to the 10th power. All right, there's one more step we can do to clean this up a little bit more. You may notice that we have 2 logs subtracted in the numerator and 2 logs subtracted in the denominator. There's this other rule for logarithms called the quotient rule that basically says if you have a subtraction in between 2 separate logs and they have the exact same base on each log, you can combine these together into a single fraction inside of a logarithm. So in our case, we can get this to be log of 9 to the 5th would go up in the numerator, 4 to the 9th goes in the denominator, divided by, for our denominators, combining those together, it's going to be log of 9 to the 10th in the numerator, 4 to the 10th in the denominator. And that's an exact answer as combined together as you can get it. You could evaluate like 9 to the 5th power and figure out what number that is, and 4 to the 9th power, etc. Hopefully we can get this into our calculator as well. I believe this works out to be negative 0.1838 ... if you needed a decimal approximation for this answer. All right, big problem, lots of steps involved, but hopefully this helps get you moving in the right direction and solving these exponential equations where you can't rewrite them so you have the same base on both sides, but instead you need to utilize logarithms and the rules that go along with logarithms. All right, till next time, good luck.